Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. Our names are Melissa
and Elise,
and we are your hosts for episode 2 called the Chernobyl Disaster. Today we will be discussing the nuclear disaster in a city in Ukraine called Chernobyl.
So for an introduction, the Chernobyl disaster was a nuclear explosion that occurred on April 26, 1986 at the Chernobyl nuclear power plant number 4 reactor. The nuclear power plant was located near the city of Pripyat in the northern part of Ukraine, which was a part of the Soviet Union at the time, engaged in a Cold War. The explosion of Chernobyl's number 4 reactor, which was an RBMK-type reactor, which we'll talk about later, released large amounts of radiation into the city. The area within a 30-kilometer radius of Chernobyl is now considered the Chernobyl exclusion zone. And to this day, there are still areas in the exclusion zone where radiation is far too dangerous for human contact.
I think there's a tourist attraction where people can go and see Chernobyl, right?
Yeah, so it's not like a tourist attraction, but if people can go to the exclusion zone and look at Chernobyl and its remains, basically. I watched a video and the lady was like, it's literally like looking at a town that's frozen in 1986, and I feel like that put a lot of perspective on. I think it would be cool, but it's also really sad. The Chernobyl disaster is one of the worst nuclear disasters, or it is the worst nuclear disaster in terms of cost and casualties. The initial emergency response alone involved more than 500,000 personnel, which included firefighters, engineers, military troops, police, miners, cleaners, and medical personnel. The cost was around 18 billion Soviet rubles, which in 2019 converted to 68 billion US dollars. And 31 people died as an immediate result, but in 2005 it was predicted that as many as 4,000 people could eventually die from radiation exposure.
I think that number is really hard to calculate because there were some lasting effects as well, right?
Yeah, because the thing about radiation, it's so hard to calculate the cost of lives because people get cancer, and I know that childhood cancer rates did go up after the explosion, but even to this day, it's almost impossible to calculate that because it's not immediate like a fire would be. Yeah. And along with human deaths, countless animals were slaughtered in Chernobyl's surrounding area in fear of their exposure to radiation. So now we're going to take a look at some of the people who were involved in Chernobyl.
So the first one we have is Legasov, who was the main chemist behind the investigation of Chernobyl and his work in the containment as well. He did commit suicide 10 years later after the disaster, partly because he knew he would die sooner because of the radiation exposure. Yeah. And a lot of people who were involved were exposed to radiation. So he had a set of audio tapes that he recorded before his death, which described his involvement with Chernobyl in full detail, which was actually really essential to the court cases because they played those tapes.
Yeah.
So, which leads us to our second person, Dyatlov, who was a Soviet engineer and deputy chief engineer for the Chernobyl power plant. He supervised the safety tests that resulted in the Chernobyl explosion, and almost everything that went wrong in Chernobyl can be traced back to Dyatlov, and he was the main person blamed for the disaster because he didn't follow safety protocols. And he did spend some time in jail for that.
Yeah.
So, and then we have Gorbachev, who was the leader of the Soviet Union during the time of the explosion.
Yeah, and more important than Gorbachev, we have Boris Sherbina, who was a Ukrainian Soviet politician who supervised the Chernobyl disaster, and he had a really large role in allowing the investigation to receive the information and resources and research that it needed. And then we have coal miners and firemen who were considered the first responders in the incident. There were obviously firemen who were woken up in the middle of the night and had to go put out the fire. They were immediately exposed to a lot of radiation. And one of the scenes from the HBO documentary, which is something that piqued our interest to do this podcast, when there's a scene where the firemen go to the hospital, they had to take off all of their uniform, obviously, because it was so contaminated, and they just threw them in the basement. And to this day, that basement, if you visit the exclusion zone, you cannot go in that basement because it's way too contaminated for human contact. And then there were also miners who were brought in to dig a tunnel under the reactor to prevent the melting core from contaminating the groundwater. Obviously, if the groundwater is contaminated with radiation, this would put so many lives at risk, more than they already were. And it's approximated that 1 out of 4 of the miners died later as a result of radiation poisoning.
I think the miners play a really key part in what happened, and
Yeah,
they really did put like their lives on the line.
they really did.
So now that we have a general understanding of the people who were involved, let's take a closer look at what actually happened in Chernobyl. But first, we have to fully understand how an RBMK-type reactor works, which is the type of reactor used at Chernobyl. So it gets a little confusing at this part, but we are going to break it down into 3 components. So in an RBMK-type reactor, we have the uranium atoms, boron control rods, and cold water. So these 3 components can be broken down into 2 categories: things that increase reactivity and things that decrease reactivity. So to start things off, the uranium atoms split apart through a process called nuclear fission, which is a chemical process that we know about. Nuclear fission is when neutrons collide with uranium atoms and cause them to split. So when this happens, this releases a large amount of energy, making it an exothermic reaction.
Which is something that we learned in chemistry this year.
Look at that. So this whole process increases the reactivity of the core. And if this reactivity isn't balanced by an external force, it will continue to rise exponentially, which is extremely disastrous, as xenon gas is a product of this reaction, and it's extremely poisonous if it's not burned off. And typically, xenon gas is burned off throughout this whole process when the reactor is working under normal conditions.
But obviously, as you've probably guessed by now, in Chernobyl's case, the reactor was definitely not working under normal conditions, which means that there was a buildup of xenon gas.
Right, so that's why it's so important to have devices like the boron control rods to decrease the reactivity of the core. So what the boron control rods do is they basically act like brakes on a car. They absorb some of the neutrons that would otherwise collide with the uranium atoms, therefore slowing down the rate of fission. So the more neutrons absorbed, the slower the rate of fission. So the more boron rods present in the core, the lower the reactivity. Now, heat is something that is released during this whole process. So to take out some of the heat, cold water is used. So the cold water takes out the heat and it turns it into steam. That steam then turns turbines which generate electricity. So to put it all together, essentially the uranium atoms split apart, which increases the reactivity. To lower the reactivity, boron rods and cold water are used.
And it's basically just a cycle if you think about it. Each part needs to work together to make sure that a nuclear power plant can function.
Right, so when there are so many moving parts in the reactor, the question that comes to my mind is what actually happened in Chernobyl? Like, what went wrong?
Yeah, so the reactor exploded in the early morning around 1:23. That night, the night crew was running a safety test, something that had been continuously put off for a few days.
I mean, automatic red flags right there.
Yeah.
I think the day crew was supposed to do that test.
Yeah,
right?
for sure. The day crew was actually supposed to run that test, but because of its delay, it needed to be run. So it was run by the night crew, and the night crew did not know the risks of the test. Another red flag.
And they weren't trained, right?
Yeah. So there was a planned decrease of reactor power in preparation for the test, but the power output actually unexpectedly dropped to near zero. Operators weren't able to restore the power plant's needed power level for the test, causing the reactor to be unstable. Another red flag. At this point, reactivity in the core had been rising, but all of this happened with Dyatlov thinking there was a foolproof fail-safe AZ-5. Under normal conditions, engaging in AZ-5 immediately causes the boron control rods to enter the core and decrease reactivity. However, in the Soviet Union, these control rods are tipped with graphite because it's cheaper, and graphite causes reactivity to skyrocket. So we didn't get to the boron part
Yeah,
of
I
the
mean,
control rods.
There are so many things wrong with that. Like, right there.
Yeah, so because we only got to the graphite of the control rods, the core melted down and exploded.
I mean, it's just so unfortunate how it happened, but there are so many working components that made it like that, and that's actually why it was so interesting to us, because it is the worst nuclear disaster in history, and we were curious about what actually happened. And
because I watched the HBO documentary,
Right.
and then I made you watch
You
like
did.
2 episodes of it.
it was very interesting, though.
It's so good.
It was really good.
Yeah.
And actually, I think that docuseries does a really good job of...
Yeah, it's pretty accurate.
It is pretty accurate.
Yeah.
And I think we were also interested about it because there is immense amount of chemistry behind the workings of a nuclear power plant. And that, coupled with the massive amount of tragedy that happened in Chernobyl, which really piqued our interest.
Yeah.
So thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.